So I hope by now we have a better grasp of the basics of similarities. We know the ratios are going to be equal, we know the angles are going to be equal. If I have one piece of the information, maybe I can conclude that the two triangles are similar, and then all the results will kick in, which I can use according to the problem or the theorem that I need to prove. So starting with a very easy example, and we want to apply that idea here. The only information given about the figure is that PQ is parallel to RS. That means this line is parallel to this line. And you are asked about OS. You have the information about PO, you have the information about QO and OR, and you are asked about OS. At an even more basic level, my question is, are these two triangles similar to each other? So can I prove that? First thing that I can notice is that these are vertically opposite angles. That means they are definitely going to be equal to each other. Now if PQ and RS are parallel lines, that means this angle is going to be equal to this angle. Two parallel lines, there is a transversal. These are the alternate interior angles. So this angle is equal to this angle. Similarly, this angle and this angle, they are also going to be equal to each other. Why? Again, this is a parallel, and this time PS is the transversal. Once again, these are alternate interior angles, so they are equal to each other. That means this angle is equal to this angle. That means if I think of these two triangles, all three angles are equal to a corresponding part. So I know that these two triangles are going to be similar. A point that I have to pay special attention to is matching the corresponding paths. So I see this angle is equal to this angle, so P corresponds with S, and however you want to write it, I am writing PQO, let's say PQO, and I want to write the similar parts or corresponding parts in order, right? So P corresponds with S, Q corresponds with R, Q corresponds with R, and O corresponds with O. O corresponds with O. Because once you write it correctly, you can look at the results in a very organized manner. PQ upon SR, PQ upon SR is equal to QO upon RO, QO RO, PO upon SO. These ratios are going to be equal to each other. And once I figure this out, I can solve this problem very quickly. I wanted OS. I don't know the value of OS. Where is OS? Here. So let me put a X here. This is what I wanted. What else do I have? Do I have a PO? I have a PO. So I can put a 6 here. Do I have a QO? I have a QO. Do I have a RO? I have a RO also. So I can put this as 8 and this as 12. And my job will be done. So this is still doing it very mathematically and mechanically. Think of it this way, the ratio of this side to this side is going to be the same as the ratio of this side to this side. So now you can, if you're familiar with ratios and multiplying factors, the multiplying factor here is 3 by 2. So the multiplying factor here also is going to be 3 by 2. So this would become 6 into 3 by 2, 9. The same result you will get from here also. X is equal to 6 into 12 by 8. This 12 by 8 is nothing but your multiplying factor, new by old. But I am going into ratios and variations in multiplying factor. Do this and your job will be done. And as you get comfortable, learn to verbalize this. This side's ratio to this side is the same as the ratio of this side to this side. Obviously, I could have also given you a question about these two sides. But once I have this piece of information, my job will be done. And another very basic agenda that we want to learn is that the triangles will not be oriented identically. So you will have to find the corresponding paths. So that is another point of this example. So let's try one more very basic example. And once again, just to get comfortable with the terms and various orientations. So I have a triangle ABC. This is the information given to me. One side is 3.8, another side AC is 3 root 3 and BC is 6. There is another triangle PRQ. PR is given as 6 root 3, RQ is given as 7.6 and PQ is given as 12. And this angle is also given. Angle A is 80 degrees, angle B is 60 degrees. And your question is, what is angle Q? So the question is not very important. We just want to repeat the process a couple of times and notice the correspondence and the ratios. So I have a 6 here and a 12. I see 6 into 2 is 12. I also notice 3.8 into 2 is 7.6. I also notice 3 root 3 into 2 is 6 root 3. It's okay if you took a minute or two to figure this out, there's no problem. What I want to notice is that this multiplying factor is the same. That means the ratio of all corresponding sides. If I do 3.8 upon 7.6, I will get 1 by 2. If I do 3 root 3 upon 6 root 3, I will get 1 by 2. If I do 6 upon 12, I'll get 1 by 2. And if you flip the ratios, you will get 2 as the answer. But the ratios of the sides are identical, which very quickly means that these two triangles are identical. Which very quickly means that these two triangles using the SS similarity are similar to each other. That means not only the ratio of corresponding sides is the same, all the angles are same. I have to figure out angle Q. That means my only challenge is which angle does angle Q correspond with. That is the only thing I have to figure out. And then I can see that 6 corresponds to 12. That means BC corresponds to PQ, right? 3 root 3 corresponds to 6 root 3. That means AC is the same as PR. 3.8 corresponds to 7.6. That means AB is the same as, not the same as, similar to or corresponding to RQ. And once I know this information and I'm looking at angle Q, I see angle Q is between 7.6 and 12. Angle Q should be between 7.6 and 12 or the corresponding sides. That means angle Q corresponds with angle B, and straight away this is going to be 60 degrees. So that is the only challenge in terms of understanding the orientation and writing it correctly, right? In this case, you don't even need to write it, just understand it and you are done. Similarly, if the question was what is angle P, let's say. So I will figure out, repeat the same process, I will figure out that angle P corresponds to angle C. Just one more extra step is needed. This angle is going to be 180 minus 140. So this is going to be 40 degrees. Once I know this corresponds to this. These two triangles are similar. This angle is going to be equal to this angle. So I know this angle is also going to be 40 degrees. So very easy problem. Just getting comfortable with the correspondence only. We already know the ratio is going to be identical. The angles are going to be identical the moment I look at similarity.